There's more and more research that's being done linking circadian rhythm dysfunction to things like depression and anxiety. And I kind of want to pick that apart here because if you are someone who works with people who have anxiety and depression, whether it's classically diagnosed or simply something that they're experiencing as a symptom, light and one's light environment is almost completely overlooked these days. And so first and foremost, I think it is helpful to share my screen. Now, this is not a clinician style presentation. This is a small webinar I did for the general public that I'm going to be showing you some slides to called Quantum Strategies for Anxiety and Depression. But what we have here, very interesting research article that showed that when you look at, I want you to like kind of orient yourself to these two little circles at the bottom that have arrows running along them. What we have here is the study, one study that looked at which genes were firing in someone who was depressed versus in someone who was not depressed, or a population, but not just one person, right, but a population of individuals who were diagnosed with depression and a population of individuals who did not have depression. And what you see in the quote unquote normal group is that there is a very rhythmic firing of genes that are supposed to be turned on at various times of the day. So for example, sunrise has its genes, the height of the afternoon, sunset, and then nighttime, right? All of that happens in a very rhythmic, coordinated fashion. What they found when they studied gene expression in individuals who were diagnosed with depression was they found that there was significant alterations in the timing. So like timing was off. When the timing is off, the body just is in what we would call a state of cellular chaos. It's almost like the state of the cell. The chaos that might be felt inside of the cell is mirrored in what one might be experiencing as their symptoms of depression. And so is it the chicken or the egg? Does someone have circadian rhythm disruption that then can trigger depression, or is someone with depression more likely to have a dysregulation in circadian gene firing or gene expression? Just based on my clinical observation, I'm going to say that circadian rhythm dysfunction drastically contributes to what can ultimately become depression. And this is through the lens now of what we understand also where there's a strong clinical link between mitochondrial dysfunction and depression. So I'm going to see if I can find that slide here. Lots of interesting stuff here. Where's my mitochondria? Lymphatic drainage. All right, hang on. Let me go back up because I must have done that first in this presentation. Yeah, so there's a huge indication between mitochondrial dysfunction and depression. Now, what do we know? Why would this be? Well, mitochondria are directly responsible for communicating what genes to express. Now, remember, we're dealing with two locations, right? The mitochondria, are inside of the cell. And then inside of the cell, there's also a nucleus. And inside of that nucleus, there is DNA. It has been well established, specifically though in Russian literature, that oftentimes has yet to be translated to English, or has just more recently been translated into English, that DNA absorbs biophotons, specifically ultraviolet light. And guess what the mitochondria make? The mitochondria are responsible for making ultraviolet light. They make it in the form of things called biophotons or reactive oxygen species. So these ROS are essentially light-producing species. And as mitochondria leak electrons, or as mitochondria become more dysfunctional, they become less efficient at tunneling electrons through cytochrome C oxidase to make water. And instead, those electrons get lost. And those lost electrons become reactive oxygen species. And these reactive oxygen species, they're okay up to a certain point. We should have mechanisms inside of the cell in order to control a burst, if you will, of increased reactive oxygen species. But unfortunately, the systems that we have in place that do help to have that help to reduce the not reduce the formation, but reduce the damage being caused by these reactive oxygen species is dependent on things that we're not getting access to these days. It's dependent on near-infrared light. That near-infrared light makes cellular melatonin that cleans up this damage. We know that earthing and grounding is a way that we can decrease oxidative stress from reactive oxygen species. So now picture someone who is in a state of mitochondrial dysfunction, making massive amounts of increased ROS, as you see in this clinical pattern at the of kind of like a flow chart on the right here. These increased ROS, it ultimately affect the mitochondria, kind of go back into affecting the mitochondria themselves. It's going to change gene transcription. It's going to reduce energy production. It's going to essentially drive mitochondrial dysfunction. And guess what? Mitochondrial dysfunction and circadian rhythm dysfunction go hand in hand. We even know that circadian rhythm dysfunction can drive mitochondrial dysfunction. And so we've got this vicious cycle these days of inappropriate light signaling to the eyes, essentially driving mitochondrial dysfunction, and then that mitochondrial dysfunction ultimately driving depression. And that changes which genes are firing. It puts the body basically into metabolic chaos. And so I highly recommend that if you are dealing with individuals who are experiencing anxiety and depression. Anxiety is a little bit different, but definitely has a very similar etiology as what I'm describing here. But with that being said, it's completely overlooked. We look to like give medications, or maybe we look to clean up toxins in one's environment, improve nutrition, right? Those are very important strategies because ultimately toxins can drive mitochondrial dysfunction. Inappropriate or, junk food, if you will, can drive mitochondrial dysfunction. So all of those are interacting with this same pathway that I'm describing here. But since the mitochondria are such prime receivers of light and they're communicating through light to the DNA, it's such an important pathway that needs to be addressed. Now we take this a step further and we see that the frequencies of light that are being emitted by screens these days are really dominant in the blue wavelength of light. And we know that mitochondria can absorb that blue wavelength range of light. And unfortunately, that inhibits water production in step 4 of the mitochondrial electron transport chain. And if not completely inhibited, it drastically reduces it. What is the wavelength range of light that we need to start to stimulate that water again? Red and near infrared light. What wavelengths are missing when we're living indoors and not connecting with the natural light outside? Red and near infrared light. So, you can see then how if we're not flowing electrons, we get essentially this backlog. These electrons start to leak. They got to go somewhere. So they start to leak and they generate these aggressive reactive oxygen species. Meanwhile, the cell phone, because of that blue wavelength of light, we also know that blue wavelength range of light increases dopamine. That's actually one of the reasons why it was originally they decided to put more blue light into office lighting. It was to maintain alertness and motivation, but we're designed to get that blue light in the full balanced spectrum, which has a huge amount of red, near infrared, and far infrared light. It also has ultraviolet light. It's constantly changing in its ratios throughout the day. In those instances, those are appropriate ways to get that blue light because it's balanced. It's a balanced light, we would call. This really aggressive blue that we see in LEDs, in bulbs and screens these days, does not come with the red and the near infrared. It does not come with the ultraviolet. So we're really getting an imbalanced consumption of this light at all times of the day. We could, wake up at 4 o'clock in the morning and get it. We could, be watching it at 11 o'clock at night. And then with that blue comes the dopamine. So every time we pick up a screen and we get that bright blue into the eyes, it increases dopamine. Add in things like the notifications there, again, driving dopamine. In individuals who are experiencing depression, they'll have drastically dysregulated dopamine levels as well. And so the screens that we're using, the fact that these screens are throwing off our circadian rhythm because we're on them into the late hours of the night, and is really impairing so much about mitochondrial health, so much about circadian signaling, and so much about the dopamine pathway that's not being looked at yet through the lens of light enough. But as a clinician who's becoming aware of how important the light environment is, it is imperative that you start to help your individuals, your clients with anxiety and depression, mitigate their light environment. Now, one last little thing about case studies on anxiety and depression. What do we shift? Well, if you're oftentimes individuals, at least in my clinical observation, individuals who have anxiety and depression are going to have a phase shifted circadian rhythm, meaning they're likely going to be night owls, way more likely to be night owls. And these night owls then are not going to be able to wake up for sunrise, or that would seem like a very daunting task to them. And so what I tell these individuals is block the artificial light at night, right? That's orange tone blue blockers. That's appropriate red screens on the iPad, the phone. You know, you can get red screen covers for televisions using appropriate light bulbs that are not overly bright, right? We're really making it a warm and orange toned lighting environment at night, darkness in the bedroom at night. And then when they wake up, as soon as they wake up, whether it's sunrise or heck, I mean, frankly, hours after, I've been working with individuals who do have that phase shifted circadian rhythm where they're waking up maybe 11, 12 o'clock in the late morning. I still have them go outside. We got to go outside, get them that light signaling, block it at night. And over time, you'll see this circadian phase shift back to a friendlier circadian appropriate bedtime and a circadian appropriate wake time. As they shift that circadian appropriate wake time more, they'll take advantage of that morning ultraviolet light, which can generate serotonin. Right? That serotonin ultimately becomes melatonin at night. So all of these things are beautifully interconnected, but we need to really coach our clients with anxiety and depression to get the correct light exposures at the correct times and mitigate it when we don't need that aggressive, toxic, artificial blue light. So hope this helps with your clients who are experiencing anxiety and depression, and I will see you next time.